Okay, section 7.5, solving quadratic equations by factoring. More factoring, it's not going away. Okay, so today we're just solving, we're not graphing, although I might graph them quickly just to show you what they look like, but we're factoring. So it says you can solve some quadratic equations by factoring them into a product of two factors, that's the easiest, setting the factors equal to 0, and then solving the resultant linear equations. I did that a little bit last lesson, but we'll do it more this one. And it says, keep in mind that an equation with two equal roots is said to have one solution. That's a graph that hits the x-axis only once. Okay, so we reviewed factoring in 7.4. We're going to go over two examples of different kinds of factoring. And the first example says, solve this quadratic equation by factoring and then verify your solutions. Two different ways to verify your solution. You just either plug the number that you got back into your equation, or you can always graph it on that online graphing calculator and see if your answers is where the graphs cross the x-axis. Okay, so this one looks pretty complicated. It's 0.125x squared subtract 0.875x equals negative 1.5. So the first thing we're going to do is we can't factor until everything is on one side and 0 is on the other. So we're going to bring this negative 1.5 over, and we're going to do that by adding 1.5 to both sides. So I'm going to write this over here just so I can have room. So I have 0.125 x squared minus 0.875x plus 1.5 equals 0. Now, there's no way you can factor this. This is too complicated. So what you can do is manipulate this so that it's way easier. And look at how I have 3 decimal places. 3 decimal places. Here I only have 1. But because I have 3 decimal places, I'm going to multiply by 1,000. Because these 3 zeros will make my decimal move here, and then I'll have 125 x squared. Well, if you multiply by 1,000, I have to multiply everything by 1,000. Okay, I'm not allowed to just do it to one thing. Everything needs to get multiplied by 1,000. So the second one becomes negative 875x. These 3 zeros make my decimal move 3 times. This last term, I'm still moving my decimal 3 times, so there's 1, and then I'm going to add 2 zeros. 0 times anything, including 1,000, is 0. All right, still kind of complicated, but at least the decimals are gone. Now, if I can multiply it by everything, I can divide by everything. And so we're lucky in this example because we have 125, okay, and which goes into 875 and which goes into 1,500. So I can simply divide, but if I do it there, which gives me x squared, I have to do it there, which gives me 7. I have to do it there, which gives me 12. Have to do it there. 0 divided by anything is still 0. Okay, something we can factor. 2 things that multiply to 12 and add to negative 7. Well, it's not going to be 1 and 12. And it's not even going to be negative 1 and negative 12, because neither of them is going to add to negative 7. Hopefully you're starting to catch on to this. That it has to be negative 3 and negative 4. So negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. So factored form is x minus 3, x minus 4 equals 0. Okay, you could have written x minus 4, x minus 3. That doesn't matter. All right, now remember, we need to figure out, because I've got left side, right side. My right side is 0, so I have to make my left side 0. Okay, so I need to put something in this bracket that will make this bracket 0, which hopefully you can tell is 3. I have to put something in this bracket that will make it 0, which hopefully you can tell is 4. Okay? You need to make your left side 0, so think, what numbers can I plug in that will make it 0? Now these ones are pretty easy to tell by inspection, but what if it was a little more complicated? All you'd have to do is take each of them and make them into 0, because that's what you're doing. You're asking yourself, what makes this equation equal to 0? And then you'd use algebra to solve, and there's your 3. Same with the other one, x minus 4. I'd add 4 to both sides, And there's that 4. Okay? So 3 and 4 is what makes this equation 0. Okay? Verify your solutions. Well, let's see if I can quickly grab an online calculator. One sec. Is there a calculator on this front page? No. Okay, we'll go to, well, we can go to the graphing calculator and see what happens there. Okay, you probably wouldn't do this while you're doing your practice, although every time you go to the back of the book, you're verifying your solution. On a test, you absolutely would do this. So 0.125 x squared minus 0.875x. And remember, we brought that 1.5 over, plus 1.5. So there's your 3. That's the vertex. There's your 4. Okay, so that kind of verifies. You could always zoom in just to see for sure that this graph goes to the x-axis at 3 and 4. So that's one way you could verify your solution. Okay. Example number 2 says solve the following equation and verify your solutions. Now this is more complicated because I've got a leading coefficient. So the 49 has to come over. I have 9x squared plus 42x plus 49 equals 0. Now, grade 10, it was hard when you had a leading coefficient, okay? And I'm not going to talk about what do you do when you have a leading coefficient, except for this one case, because I'm not going to give you ones that aren't like this case. What you need to recognize about this case is that this is going to be a perfect square. Look at how 9 is a perfect square. 49 is a perfect square. So in grade 10, I talked a lot about if you can recognize that this is a perfect square, you factor it based on that. So 9x squared comes from 3x. 49 comes from 7. Everything's positive, so put pluses. And then what you do is you check if it works. You make sure, is this a perfect square? It looks like a perfect square. I start with a square and I end in a square. So what you do is you expand and you just make sure that it works. So 3x times 3x is 9x squared. 3x times 7 is 21x, and 7 times 3x is 21x. 7 times 7 is 49. There's the 9x squared, there's the 49, and 21x and 21x make 42x, okay? So if you can recognize it's a perfect square, they're actually very, very easy to solve. I'm not going to ask you to do ones that aren't, okay? So get the hang of this and you'll be able to do them. Now remember what we're doing. We're trying to see what can I plug in here that will make it 0, because look at my right side. My right side 0. I have to make my left side 0. So this is one of those examples where it's not going to be as easy to tell if what makes it 0. So you just take your brackets and you make them 0. I'm not going to do it twice. They're exactly the same. I'm just going to solve one of them and it would be the same answer over here. So using algebra, I'm going to subtract 7 from both sides to have 3x equals negative 7 divided by 3. So x is negative 7/3. Okay, that's your answer. You have it twice. We call this a double root. And what it means is the graph, I don't know exactly what it looks like. My y-intercept is here at 49. My x-intercept is here at negative 7/3. Graph looks something, oops, pretend I touched it. Looks something like that. It bounces off and it just touches at exactly one place. So this is roughly negative 2.3333. So let's go back to that graphing calculator and let's graph it and let's see what this looks like, okay? And let's see if my x-intercepts are negative 2.333. Nope, I already had it open. Here it is. Okay. So 9 x squared plus 42, oops, 42x plus 49. Let's look at it a little closer. And there's that negative 2.333. Okay, so we call that a double root. That's why each factor was exactly the same. This graph doesn't come through and back up. It touches exactly at one spot and then goes back up. So when it's one of these, this is actually the vertex as well. Negative 2.33 and 0 is the vertex when it's one of these ones that have a double root. So in your homework, if you've got this leading coefficient happening, it's going to be one of these kinds because I'm not going to ask you to do the other ones. Okay? All right, good luck.